number 65 on section 5.2. To estimate the height of a mountain above a level plain, the angle of elevation to the top of the mountain is measured to be 32 degrees. 1,000 feet closer to the mountain along the plain, it is found that the angle of elevation is 35 degrees. Estimate the height of the mountain. So we have a mountain here. You know, for the sake of, oops, drop my pen. You know, for the sake of the simplicity, we're going to just kind of consider a height like that. But, you know, the mountain would be kind of like this or whatever, right? So we're driving. When we're at this point, the angle of elevation, now remember, angle of elevation is always measured from the horizon, so it's this angle right here. That would be 32 degrees. And then as we drive closer, another 1,000 feet closer, the new angle of elevation is 35 degrees. That makes sense, that as you get closer, you have to look steeper up in order to see the mountain, right? All right, so the problem with this is I have a hard time using trigonometry. I have two right triangles. I got this big one, and I got this small one, but I don't know any of the sides to either of those in its entirety. So it's kind of a little tricky, I guess. Let's call this quantity here x, and I want to find h. So I have really two unknowns. I kind of got to find this so I can find this. So I need two equations, but that's okay because I got two triangles. So for this triangle here, this triangle, I have a trig angle related to two sides that I want. This is the opposite side. This is the adjacent, opposite and adjacent. So that equation is the tangent of 35 degrees equals h over x. So there's one equation with one unknown, and then the other equation is going to be looking at the big triangle. For the big triangle, the tangent of 32 degrees is equal to the opposite, which is h, over the adjacent, which is x plus 1,000. So what we have here is a system of two equations with two unknowns, and we should be able to solve it. Okay? So how are we going to do that? Well, I want to solve it for h. So I don't want to eliminate h. Let's eliminate x. So I'm going to solve this equation for h to eliminate, for x to eliminate h. X equals h over the tangent of 35 degrees. So if I plug this x into here, well, first of all, it's going to be a little bit of a mess. Maybe I should have just solved for x first and then found h. Well, whatever. I'm going, so I'm going to finish it. So let's plug. So that's the this new equation here is the tangent of 32 degrees equals h over tangent of 35 degrees plus 1,000. Yikes! It's kind of looking a little ugly. Contemplating changing this would have been easier to solve this for h, I think. I'm going to finish it. I don't care. Cross multiply. 1 times h is h. This times this. This times this. Oh my goodness, sorry. That would be h times the tangent of 32 degrees over the tangent of 35 degrees plus 1,000 times the tangent of 32 degrees. I want to solve it for h, so I got two h terms. Let's get them on the same side. I have h minus h tangent of 32 degrees over the tangent of 35 degrees equals 1,000 times the tangent of 32 degrees. Now I got my h's together. Let's factor out an h. It leaves me with 1 minus tangent of 32 degrees over tangent of 35 degrees. Now this is just a number. It's got some fancy tangents in there, but it's just a number. So let's divide by that number. So my final answer is h equals 1,000 tangent of 32 degrees divided by 1 minus the tangent of 32 degrees over the tangent of 35 degrees. Now this is my exact answer. However, I don't really like this exact answer because it's not simplified. I can't have this complex fraction in the bottom. But this is a word problem. I don't think anyone really cares about the exact answer on this. We just want the approximation. And I don't want to go through the work to simplify this so it looks nice so I can put it in my calculator. So I'm just going to put that in my calculator and pause the video while I do it. If you want to stop the video and just put it in your calculator, you can. But I do want to talk about how to handle degrees and radians. I think Ms. Bainey maybe does it a little bit different than I do. So I am going to show you how I type this in the calculator. I want to point out to you that my calculator is always in radian mode. I never take it out of radian mode. Now this problem's got its inputs in degrees, but I can overwrite radian mode by putting in degree symbols. So here's what I'm going to do. Let's start typing it in. Control fraction button, 1000, tangent of 32. Now if I put in 32, just like when you're working on your homework or whatever, if you put 32 with no units, it's assumed radians. But if you put degrees there, then it's degrees. So if I hit this little button right here, right below the enter key, and select this little degree symbol, this is going to overwrite the radian input and make it a degree input. That's how I like to work with my calculator. I don't like switching back and forth from radians to degrees, and you really don't need to, as long as you know how to use that degree button. Now, if you're in degree mode, you can't overwrite degree mode and put in a radian measure because there's no measures when you're, if your calculator's in degree mode, you can't overwrite it and make it a radian measure. So this is going to overwrite my radian mode because everything's in degrees. And I should put down degrees anyway, right? Control, enter. 5,800 and let's say 5808. 5,808 units. Since this 1,000 was in feet, I'm assuming my h is going to be in feet. Boom.